Application of stack. The first application is parenthesis matching. Now, parenthesis matching, parenthesis when we talk about, think as if it's your small bracket. So we will not include a curly braces or square braces over here. It is a small braces which we are using here. Okay, so given a expression, you can find this is one of the expression. You're supposed to figure out whether the expression is a balanced expression or not. Suppose if it's a balanced expression, then the parenthesis, what you have, left parenthesis, and its equivalent right parenthesis counterpart should be uh, displayed in the by the program. For example, when you look at the string a star b plus c plus d, so the left parenthesis positions are located at 0, 3, and right parenthesis locations are at 7 and 10. Okay, so 0 parenthesis, its position counterpart, equivalent right parenthesis counterpart is at position 10, and for the third left parenthesis, its equivalent right parenthesis counterpart is at location 7. So the objective of this program, parenthesis matching, what you're supposed to do is, as you come across or as you encounter a left parenthesis, it has to be pushed onto the stack. Scan the string from left to right and place all the left parentheses whichever you come across onto the stack using push operation. And whenever you encounter right parenthesis, the top content, using the top function, grab the top content of the stack, and that has to be matched with the right parenthesis. So for grabbing the data from the stack, we will be using pop function. So push is used as soon as you encounter left parenthesis, and pop will be used whenever you are encountering right parenthesis. Okay, so what is the data you will be placing onto the stack? So the positions of the left parenthesis is actually the data which you are going to put onto the stack. For example, for this expression, the positions 0 and 3 should be added onto the stack. And as you come across the position 7, its equivalent counterpart, because 0 will be moved first followed by 3, so 3 will be the topmost element and 3 will be the counterpart of the position uh, um, 7. 7, its equivalent left parenthesis is at 3, so that's how you get. So add the element onto the stack and grab that element from the stack whenever you encounter right parenthesis. Recent, we call it as grabbing, or we call it as a most recently added left parenthesis, that should be taken out. Okay, so we will go through the program once. I've taken 3 examples, and how this program works. You have an example over here. So for this example, let's try to figure out what's happening in this program. Okay, so first example, we will consider a balanced expression wherein you have a, left parenthesis a, left parenthesis b, left parenthesis c, then you have right parenthesis 3 times. So altogether, the length of this expression is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is actually the string length. The expression is string sequence of characters with a, b, c, left parenthesis and right parenthesis, and this is a balanced expression. Now, as addressed, I want the positions of left parenthesis, which happens to be 0, 2, and 4, to be pushed onto the stack. And once it gets pushed, this is how the stack looks. Initially, it will be 0, then 2 gets added onto the stack, then 4 gets added onto the stack. So you have the configuration of the stack as addressed here. Then when I is equal to 6, the position I is equal to 6, that's the first occurrence of right parenthesis. So when we are here, grab the top element which is 4, and we display the message 4 6. What does 4 4 is actually the left parenthesis, and its equivalent right parenthesis position is 6, and that's correct. Okay, and the data is removed from the stack. Then again you have to redo the process for till the string is completed. Okay, now let's go back to the program. First line you have array stack. So we have two types of stacks earlier addressed: stack created using arrays and stack created using linked list. We are using stack created by array here, and integer stack we are supposed to create because the positions of the left parenthesis is stored and the positions are always integer, and s is actually your stack. So now you can make use of s dot function and you can invoke all the methods like push, pop, top, so on and so forth. Okay, so first we will try to see what happens when you're invoking the function int length is equal to int of expression dot size. So expression is a string which is an argument which printed match by pair stakes. So here this example, this is your expression with the length 9. Okay, so you compute the length is equal to integer, translate, cast this expression to integer, and you're going to get the value 9 here. For this example, the length is 9 and we scan all characters in this expression. So for int I is equal to 0, I less than length I plus plus. So first we check the occurrence of left parenthesis. If expressions dot at of I, so what is this dot at of I? This is vector based notation. Dot at of I, dot at of begin, dot at of end. So just think as if we are scanning element wise the expression is scanned. So I is equal to 0, expression dot at of 0, you have a left parenthesis in this expression. When we look at example 1, I is equal to 0, left parenthesis we have, and we are searching whether it is a left parenthesis. Suppose if it's a left parenthesis, then push that, what push the position. So I is actually the value 0. I is 0 because at that location we have left parenthesis, so push 0 onto the stack. So now you get this pictorial diagram, whatever is it is, so you'll get this stuff. Next we take the value of I is equal to 1. Again the expression has now a, so a is neither left parenthesis nor it is a right parenthesis, so I will be skipped. So I is equal to 1 is done. Then we have again left parenthesis, second occurrence of left parenthesis, so the position is 2. Now when I is equal to 2, expression at of 2, it is exactly equal to left parenthesis, so push that I value onto the stack. So after doing this is what we get, 2 will be at the top, then we have 0. Okay, then again we have b expression is at position 3, I is equal to 3, that is skipped because it is not left parenthesis, neither it is right parenthesis. Then we move on to I is equal to 4. I is equal to 4 location you have again left parenthesis, so this left parenthesis is at the position 4. 4 will be moved on to the top of the stack. So the stack configuration is this: 0, 2 and 4. The topmost element is 4. Now the value of I is equal to 4. Next I becomes 5. When I is equal to 5, you have the expression at of 4, 5 value as 6. C is neither left parenthesis nor it is right parenthesis, so this is skipped. I is equal to 5 is skipped. Then you have I is equal to 6. So when I is equal to 6, you have this expression is false, else we check is it expression dot at of I. So the reason why we have used try and catch clause over here is there is a chance that when you compare right parenthesis, you might get stack empty. If you're in that stack empty condition, then catch clause will be executed. If there is a valid number of elements in the stack, then this try block will be executed. So now you're in I is equal to 6. When I is equal to 6, you work upon this. So I is equal to 6, see out, get the topmost element. So it prints s dot top. What is there in the top of the stack? Top of the stack element is 4. So print the element using top function. So 4 will be printed here. then you print a message I. So what exactly it suggests is 4 is the left parenthesis and its equivalent right parenthesis counterpart is at a location 6. So 4 and 6 are the balanced expression. For 4, 6 is its equivalent counterpart. Okay. Then what we do is we pop the item. So we are supposed to destroy this. The 4 which we have now on the top of the stack should be removed. So removing is done using pop function. So you are invoking s dot pop. So the topmost element will be removed. Then we move on to the next iteration when I is equal to 7. So you can find it is the second occurrence of right parenthesis. When you have second occurrence of right parenthesis, the value what you have top element now, that is this execution takes place again, try clause, because you have a valid number of elements. Now you have s dot top. So what is s dot top? Top element right now it is 2. So 2 will be uh, taken out, 2 will be displayed, and 2 will be displayed, and its right parenthesis counterpart is at a position 7. So 2 and 7 will be printed along with. So after that, pop the element. So you have 2 removed from the stack. So you have only one element now, 0. That's the topmost element, and the size of the stack is 1 now for I is equal to 7. Then go to I is equal to 8. That's the last iteration. When that's happening, then you get the 0 will be taken, and its equivalent counterpart I is equal to 8, because at I is equal to 8 you have the third occurrence of the expression closing bracket. So now this element is destroyed, so the stack is empty now. Stack is empty, and this iteration is completed, and you check this condition while the stack is not empty. Stack is empty, so this instruction will not be executed now. So you are returning from the function. When you are returning back from the function, it is going to display this message now, 462708. So this is actually the status of the left parenthesis and right parenthesis as you have. So it doesn't produce any error message as such, and the expression is balanced expression right now. Now let's look at a second example wherein we have expression when the excess number of left parentheses and a less number of right parentheses. We have 3 left parentheses and 2 right parentheses. Left parentheses are located at indexes 0, 2 and 4. Right parenthesis is located at an address 6 and 7. Now for this, what happens initially when we are working with this code? So first I is equal to 0, uh, I is equal to 2, I is equal to 4. For those values of I, the left parenthesis position will be pushed, and this is how the stack looks. This is similar till I is equal to 6, till I is equal to 7, everything is same. Okay, so till I is equal to same process it is. Okay, um, what happens when I is equal to 7, that needs to be looked at. So one second, I is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8. This is example 1, sorry. So sorry, I am supposed to work with this example. So example 2, first you have this as the elements position 0, 2, 4. Excess left parenthesis you have, right parenthesis 2 in number. So first, when I is equal to 6, the top element will be taken back, and 4 you have, 4 will be removed, and the position for 4, its equivalent right parenthesis is 6, 4, 6. This is similar. Now you have 2 elements. Similarly, when I is equal to 7, you have now this I is equal to 7 is actually last iteration, because total number of elements in the expression is now 8. It is not 9, which was previous. Now we have 0, 2 earlier. Now you have only one element, so it has left parenthesis 4, 6, 2, 7 equivalent, but for 0, for the 0 data, you don't have its valid right parenthesis, because right parentheses are limited. So when I is equal to 0, 7, last iteration, you have one element which is the top element, and this top element is not empty. So let's look what happens here when I is equal to 7. When I is equal to 7, the last iteration, uh, this is not uh, this character I is equal to 7, this will not be executed. This will be executed. I is equal to 7, 0, 1, 2, 3, 4, 5, 6, 7. Yeah, so 7, this much, this is executed. When I becomes 8, you have one element now in the stack. When I is equal to 8, you have one element remaining in the stack. So what happens in that case? When I is equal to 8, you are going to execute this try clause. Try clause works only if the stack is empty, not empty. So you have the try clause not empty. So what happens? This will be the top element. Top element will not be displayed. Rather, this execution terminates. You don't have any a message displayed here. The element when I is equal to 8, this complete stuff will not be executed at all, and you directly move on to while statement. So I iteration till 8, it works fine, but nothing happens as such. The positions, this you will get 4, 6 and 2, 7 is valid, but for 0 you don't have its equivalent right parenthesis counterpart. So when string is empty, you execute or display the message no match for left parenthesis. Grab the top element. The top element right now is 0, and display a message no match for left parenthesis at 0. So you'll get a message no match for left parenthesis at 0. This will be the situation. For example 2, when you have less number of right parentheses and more number of left parentheses. The last example depicts when you have less number of left parentheses and you have more number of right parentheses. So this has the size 1, 2, 3, 4, 5, 6, 7. The size is 7 again. 1, 2, 3, 4, 5, 6, 7. So you have 3 right parentheses, 2, yeah, 7. So 7 is actually the size. C isn't there now. So positions for which should be pushed onto the stack, you have only 2 left parentheses, 0 and 2. So 2 is the latest pushed data, and 0 is the previous data. So when I is equal to I is equal to 4, I is equal to 4, because B is at position 0, 1, 2, 3, 3. Fourth position you have right parenthesis. When you are working with right parenthesis now, when I is equal to 4, so 2 and 4 you'll get, which means you have 4 for the right parenthesis 4, its equivalent left parenthesis counterpart is at the position 2. That is correct. I have only one element now. 0 you have, I is equal to 5. Now what happens for 0th position, its right counterpart is at position 5. That is correct. But now since you are performing pop operation, there is no more content available in the stack, but I value is 5. The last iteration will also execute when I is equal to 6. So this try block or catch block, try block will not be executed, rather catch block will be executed, because this is an exceptional case wherein the stack is empty now. The stack is empty, but the iteration is not completed. The last character is being accessed, and that is a write bracket now. So else if statement is valid. In this, since stack is empty, try clause will not be executed, catch will be executed. So in the catch clause, we use no match for right parenthesis at I. So what we expect here is no match, stack is empty, statement inside the catch will be executed. That is no match for right parenthesis at 6, because stack is empty at this case. So that's, you're getting a message now, no match for right parenthesis at 6, which means this is an unbalanced expression. Okay, so this is what the code program is about parenthesis expression. We will discuss about towers of Hanoi if required, probably in the next class. Thank you.